Welcome to Science Wars, chemistry, bio, physics, mathematical, which field is best? I understand the force and energy, quantum mechanics and relativity. My field is pure and they rely on me. I see the universe like nobody. You may have made fun of me in high school for being awkward and following the rules. Now I've got lasers. Wow, that's really cool. May the mass times acceleration be with you. Atoms, entropy, dark matter, string theory. If you want to feel a bond, then I can give you a good reaction. The elements that make up life are my essence and my satisfaction. All the other fields out there are so basic, yeah, I'm the central science. Keep your eye on me, I'll get you charged. If you need me, call me up on Avogadro's number. If you leave me, take a titrant, shove it up your acid buffer. Dopamine and serotonin will keep you good and happy. Just get your flights, get your glass all set up, and begin to understand the world. Within me, you'll find life's beauty. From genetics to ecology, symbiosis and not division, unless it's mitosis.
Welcome back to Philippines Uncut. I'm your host, Buddy Conan. Tonight's topic is amazing science, and joining me still is Dr. Rohel Maricese, the National Space Development Program and experts in many fields of science, including astrophysics, drones, satellites, and astronomy. Dr. Sese, welcome back to our second segment. Now that video you just saw, it's a funny video. It's actually from YouTube by a group called ASAP Space, and it's precisely what we were talking about in the first segment, a group of young guys trying to make science cool and hip and relatable to the new generation, put it that way. And what we said was one of the major challenges for you guys is to reach out really to make science relevant. No? Now, talking about relevance, we mentioned before we stopped for our break that Laos, some countries are actually, just a few countries are behind us in ASEAN, Laos, Myanmar, and Brunei, and we're number 7. We've actually fallen back since our last discussion.
Yes, actually. So because of that, it's a lot. It's time that we do something so that we can catch up, not with advanced nations, but even within our ASEAN neighborhood. Because one of the things that most people don't realize is we use a lot of our space technology. We use space in our everyday lives, and we're not even aware of it. For example, like the cooking ware that we use in the kitchen, the non-stick cooking ware, which is from Teflon. So those were initially created or developed mainly as coating material for space vehicles.
Yes.
So that's one. But eventually it trickled down, and then we have a branch or an area known as space medicine. And what happens is in space medicine, scientists try to understand what is the effect of space on the human physiology. And one of the most striking things that was found out is that when an astronaut is in space, the bones actually degenerate.
Because there's less weight.
There's no gravity because of the microgravity. So there's an accelerated bone necrosis that's happened. That's why most astronauts don't stay more than 1 year. Very few astronauts stay more than that. But that kind of research is very much similar on how to address, for example, osteoporosis.
Yeah.
So that translates to something that is usable not just by astronauts, but also by other people who is afflicted with osteoporosis.
Yeah. Now, Dr. Sese, you're a program leader of the National Space Development Program, and it sounds, as I said earlier, it sounds very like a very impressive. It sounds very impressive, no? It sounds like something very first world, something that the Americans, the Japanese, or developed countries should and would undertake. Now, my question is, for people watching now and they hear something like this, they're going to say, what is the relevance of having a national space development program in the Philippines when there are so many other areas that need to be addressed, like poverty, education, things like security, things like that?
Because, as I said, space technology can be used to address or to help in addressing these areas. Like, for example, in terms of national security, when we talk about how do we know that our territorial waters are not being infringed, the only way for us to efficiently do that, to see, because we have a large maritime domain, essentially our seas are very open, and we have very few boats that can patrol the whole ocean. So we can do that through satellite imagery. So we can essentially see where are the ships within the area, and which among these ships are the what we call friendly
Now,
ships.
this National Space Development Program seems like you guys want to focus really on satellite technology, because when you hear something like this, you'd think you're planning to put someone in space. I mean, is that correct? That you guys are espousing, focusing on, or greater emphasis on satellite technology?
Not necessarily, but satellites is actually one of the tools that we can use when we do space development. We have other tools like we call satellites because these are upstream technologies. These are the ones that generates the information for us.
Yeah.
But then, in order for us to make that information usable to society, we have the downstream sides. That's where you try to process the imagery, try to analyze from the image what's the extent right now of deforestation that's happening in our country, or in some cases we can even see oil spills in our waters. So how large is the extent of that oil spill, and how that would help us in addressing how to contain that
maybe
kind
also
of oil
destruction
spill.
of reefs and things like that.
Exactly.
Coral reefs, no?
And even in basic areas like agriculture.
Now, you mentioned that we are one of the few countries in Asia who doesn't have, one of the few countries that doesn't
In
have its
ASEAN,
own,
yes.
in ASEAN
Yes.
doesn't have its own satellite.
Yes.
So, which don't have it, I mean, the Philippines, is there anyone else?
Well,
who else doesn't have a satellite?
In terms, the Philippines, we
The-
now
the
have one.
Diwata,
We
that
have now.
microsatellite, that
Yes.
microsatellite, which
Yes.
is used for...
It's actually for an experimental microsatellite. So
okay.
it's
So it's not really
because it's the
something-
first time that we've
Okay.
we've done something like that, and
Yeah.
we did it with our partners in Japan. So
Yeah.
it was a collaboration between the Philippines and Japan.
So it's not
So-
being used for any kind of imaging or
It's designed
telecoms.
to take images, and then let's see. They try to see how they can use those kinds of images. I think that's one of the things that has to be clarified with the Diwata microsat, because when the launch was was imminent, a lot of people were saying, "Oh, we can use this for this and that."
So it's a really experimental
yes,
satellite.
there was a certain level of hype and a very
Expectation.
high level of expectation for the Diwata's microsatellite. But it's actually an experiment.
So it's not a working satellite in the sense that...
It's a working satellite in the sense that it can be used,
But it's not
but it's
servicing...
not really designed for operational
Oh, okay.
purposes.
All right. I mean, for those purposes we just mentioned, like maritime
It can
surveillance and things
can
like that.
assist, but
Yeah.
it should not be the main
Yeah.
source of
It's
that.
not equipped yet to be like other satellites
Like
are.
a full-blown
full-blown
yes,
satellite.
yes.
Okay, let's talk about astronomy. How does this tie up now to your space program? We have a very nice telescope here behind us. Tell us a bit about this wonderful
Okay.
apparatus you brought to the studio.
Yeah, so when we talk about space, it's actually the two broad categories is the looking up like category, which essentially from the Earth you're trying to look up into space, and then from looking down, that's the other side, the one we've been discussing, the satellites. So here we have the other side of the coin, which is astronomy. So we use telescopes. Well, this is an optical telescope. There are other types of telescopes like radio telescopes.
Yeah.
So we use this to image or to see a lot of our distant objects like galaxies, stars, nebula, clusters, and so on. And how does this tie up to the space program is that we try to use astronomy as what we call the gateway to the sciences, because almost everyone of us at some point in
Has
our
looked
lives
up in the sky
yes,
and wondered,
we were fascinated
Are
with
we
the
alone?
stars, or we wanted to become astronauts or things like that. So we try to make this as a gateway to encourage students to go into careers like science, what we call the STEM career: science, technology, engineering, and mathematics. So because anyone can look up in the sky and be fascinated.
Absolutely, I don't know anyone who's not fascinated looking at the stars.
So,
Huh?
and one of the, for me, one of the profound things that I experience whenever I look into a telescope is that when I'm looking at a galaxy, it's like, okay, so this is a galaxy containing billions and billions of stars, and I'm just in one small part of the
Absolutely.
universe.
It's very
so
humbling,
so
no?
it's very humbling. It gives you a
Absolutely.
sense of perspective about how immense
Absolutely.
our universe is.
Absolutely.
So,
I wish everyone, starting with our politicians, would look
Yeah.
through a telescope
Yeah.
and see that, I mean, when you look at what's out there, everything you think is so important down here actually
it
becomes
suddenly it becomes it
not
becomes
so-
very trivial.
It looks very trivial. Now, I understand that you have a company and that you use this actually for your work in your company.
Yeah, a lot of people actually have telescopes here in the Philippines, and what we try to do is we try to increase awareness in astronomy.
Yeah.
In fact, we even have a lot of amateur astronomy groups in the country, and we have a lot of very good astronomers and astrophotographers who take images of galaxies, nebula. Of course, not in urban areas because it's very very hard to do that.
Because of the pollution.
Because of
Yeah.
actually
And the light.
because of the light,
And the light, yeah.
pollution. We call it
Coming
light
from
pollution.
the buildings and things
Yeah,
like that.
but when you go to the really rural areas, middle of nowhere, middle of the sea, you can actually see very good
How
images.
powerful is this scope?
When we talk about the power of a telescope, mainly it's
What can you see? Let's say, I mean, looking at if you had
actually
one of these
for
things.
using this simple telescope,
Yeah.
we've imaged galaxies.
Wow.
We've seen galaxies here. So, but then there's sometimes there's a misconception because we're used to seeing the very nice photos from
National
from
Geographic
National
or
Geographic,
Discovery Channel.
Discovery Channel, and then when people look into the telescopes, like that's it. That's so sometimes they get disappointed. But we have to understand that what we see in the photos are actually accumulated image. It's not just one image.
Are there any observatories in the country that people can go to? Because I personally would love to go and spend a few evenings, look through the telescope with an expert like you, and and just study the celestial bodies. Very interesting.
In terms of observatories, our biggest or the largest observatory that we have is the Pag-asa Observatory, which is in Diliman, Quezon City. So,
But Diliman, center of town, right? Must be
yes.
difficult to see.
Yes.
really
Well,
clearly,
in fairness to Pag-asa, they were there first because they were there in the way back 50s, 60s when it was still
When it was still,
Kogonan
open
and
land and
open land,
provincial,
yes.
huh?
And suddenly, because of urbanization, it got encroached. So it's not their fault that it's there. But the one in Pag-asa and right nearby is the NISMED Observatory in UP. The one in Pag-asa is actually the largest telescope that we have in the country right now. It's an 18-inch, about half a meter in diameter, or 45 centimeters in diameter.
Yeah.
So,
Quickly, what about the Manila Observatory? I went to Ateneo, and we, there was always something. There was always that observatory that was there.
yes.
What's going on? I mean, are you aware of anything happening there?
Historically, Manila Observatory was the one who started modern astronomy in the Philippines way back 1890s.
Okay.
Time of the Philippine Revolution, they've been doing that.
Wow.
The Jesuit priest, Padre Faura, were already doing that. But even until the 70s, they've done a lot of astronomy work. They were one of the first to do radio astronomy in the Philippines, which is, I think, much more suitable for the Philippines, given that we have half of the year that's cloudy. Basically, you have a very nice view of the clouds through the telescope. But with radio astronomy, you can penetrate cloud cover, although it's not as exciting or it's not as appealing as optical astronomy. But now Manila Observatory is more focused on climate research.
Okay. Also very
which is also important.
Absolutely.
Exactly.
Absolutely.
And they use space technology because they use satellite imagery to assess which areas are prone to hazards, prone to flooding, prone to...
Very good, very good.
Yeah. So,
Yeah. Dr. says we have paused for a break. It goes by very fast. But when we come back, we're going to be talking about more of astronomy. Then we're going to segue to this interesting thing in front of me, which is actually my personal topic tonight.
Okay.
Drones. So,
Yes.
guys, stick around because more of Amazing Science when Philippines Uncut returns.